Hello everyone, I am Sai Prasad Makuni here to represent our CI activity entitled as Block Diagram Modeling of Control System, Open Loop, Closed Loop, Feedback, Block Reduction, PID Controller Design and Simulation under the guidance of Dr. Vijay Kumar sir. And our group members are Kaustubh, Amit, Sridhar and me. Okay, so first we see introduction of our system. So control system are an essential part of modern engineering and technology used to manage, command, direct or regulate the behavior of dynamic system. These systems are widely applied in industries such as manufacturing, robotics, aerospace, automotive system and power generation. The primary goal of control system is to maintain the desired output by controlling the input signal even in the presence of disturbances and uncertainties by ensuring the accuracy, stability and efficiency. Control system significantly reduce the human efforts and improve system performance. One of the most effective way to represent and analyze control system is through block diagram modeling. A block diagram is a graphical representation that shows the relationship between different components of system using blocks, lines and summing points. Each block represents a specific function or operation while arrows indicates the direction of signal flow. The method helps is visualizing how input signal are processed step by step to produce the output. It also allows engineers to easily understand complex systems by breaking them down into smaller manageable subsystems. Control systems are mainly classified into two types: open loop system and closed loop system. In an open loop control system, the control action is independent of the output. This means there is no feedback mechanism is to compare the actual output with the desired output. Examples include electric heaters, washing machine with timers and traffic signal system. While open loop systems are simple, economical and easy to design, they are less accurate and cannot automatically correct errors caused by disturbances. On the other hand, a closed loop control system uses feedback to improve system performance. In this system, the output is continuously monitored and compared with the desired input. The difference between them, known as the error signals, is used to adjust the system input. This feedback mechanism helps in reducing errors, increasing accuracy and improving system stability. Examples of closed loop system include automatic voltage regulators, speed control of motors and temperature control system. Although these systems are more complex and costly, they provide better performance compared to open loop system. As control systems become more complex, their block diagrams can involve multiple interconnected components, making analysis difficult. To simplify such systems, block diagram reduction techniques are used. These techniques involve combining series, parallel and feedback connected blocks into a single equivalent block. Reduction rules such as moving summing points, shifting takeoff points and eliminating feedback loop helps in simplifying the overall system representation. This makes it easier to determine the transfer function and analyze system behavior. To enhance the performance of control system, especially closed loop system, PID controller are widely used. A PID controller continuously calculates the error between the desired and actual output and applies corrective actions based on the three components: proportional, integral and derivative. The proportional term reduces the present error, the integral term eliminates steady state error and the derivative term predicts future error and improves system stability by properly tuning these parameters. A PID controller can significantly improve response time, reduce overshoot and ensure system stability. Then we see objective of our system. The main objective of the system on block diagram modeling of control system are to develop a clear understanding of system representation, analysis and performance improvement techniques. The detailed objective are as follows. So we see to understand the fundamental of control system, gain knowledge about the basic concepts, components and working principle of control system used in engineering application. Then to study the block diagram representation, learn how to represent complex system using block diagrams including blocks, summing points and takeoff points for clear visualization of signal flow. Then next one is differentiate between open loop and closed loop system. Analyze the working advantages and limitations of both types of system and understand the importance of feedback in improving system performance. To understand feedback mechanism, study how is used to compare actual output and desired output and how it helps in reducing errors and increasing system accuracy. Then, to apply block diagram reduction techniques, learn various rules such as series parallel and feedback reduction, as well as shifting of summing and takeoff points to simplify complex system.
Hello everyone, I am Amit Tomre. Hello everyone, I am Amit Tomre. I am explaining the open loop control system. This model represents the open loop control system. At the input side, we have a step input signal and which gives a sudden change from 0 to 1 at a specific time. This input is applied to a transfer function block and which defines the system dynamics. The transfer function is and the block process the input and produce the system output. The mux multiplexer is used to combine both the input signal and output signal so that we can compare them together. Finally, the signal are displayed on a scope where we observe system behavior over a time. Since this is an open loop system, there is no feedback, so the output depends only on the input and system characteristics. Now we see the waveform of this open loop control system. This is a waveform of open loop control system. The yellow line is indicate the step input which suddenly increase from 0 to 1. The blue line is represents the system output. From the graph, we can observe that the output does not settle immediately and it shows oscillation indicating the system is under damped and the amplitude of oscillation gradually increases, showing the system may be unstable or poorly damped. The output keep rising instead of settling at a constant value, which indicates lack of stability due to feedback control. So, from this waveform, so overall the system shows that the oscillatory and unstable behavior in a response to the step input. Thank you.
My name is Sridhar Kishore Dhanwate. First of all, step input block. This block provides a desired value to the system. It is usually a step signal, sudden change from 0 to 1. It represents that output we want to the system to achieve. Summation block. Summation block. This block compare input and feedback signal. It has two signals, positive input and negative input. It calculates error signal. Transfer function block. System and plants. This main part of the system where actual processing happens. It represents the mathematical modes of the system. It shows how input error is converted into output. This numerator and denominator define system behavior like speed, stability, and response. A feedback path. This block sends the output back to the summation point. It helps in continuous monitoring. Usually feedback is a negative to reduce error. Function, if output increase too much, feedback reduce it. And if output is less, feedback help increase it. Mux. Mux blocks. These blocks combine a multiple signal into a one. Here it combine input signal, output signal, yellow line, input, step signal, sudden change from 0 to 1 at t is equal to 1. Blue line, output of the system. Before system t 1, input is equal to 0, output is equal to 0. System is at a rest, no response. At a step input t is equal to 1. Input suddenly become 1. System start responding. Rise time. Output start increasing from the 0 toward 1. This is called rise time. How fast system responds. Overshoot. Output goes above input 1. around 1.1 to 1.2. This is the overshoot. Reason system react quickly and needed desired value. Oscillation output goes up to the down presently. These are the oscillations. This shows the und- undamped, not perfectly stable utilization. Setting behavior oscillation slowly reduce, but here they are still present. System is trying to reach steady value. Steady state condition output keep oscillating around input 1. Ideally it should become constant, but oscillation are still so system is not fulfill settled.
Hello, my name is Kaustubh Bhosle and here I am explaining the PID control system. This model represents a PID control system which is widely used in control systems to improve the performances. The first, the component is the input signal which acts as the reference or the desired value. Next we have the comparator block which is nothing but the summing block where the actual input is subtracted from the reference input. This gives us the error signal. Then next, this error is then processed by the three components of the PID controller. Here we can see that three blocks are arranged in parallel manner. The upper one is the integral block, the middle one is the proportional block, and the lower one is the derivative block. Let's see the function of each block. First of all, the proportional block. Proportional block multiplies the error by the constant gain. Here the gain is 5. It provides the quick responses. Then next we have the integral block. It integrates the error over a time. It helps to minimize steady state errors. Then the lower block we have the derivative block. It differentiates the error, it predicts the future error and improves the stability. All these three outputs are summed together and passed through the plant function, which is here we have used the transfer function as the system. Now the output of the transfer function is given to the multiplexer, and also the output of the step signal is given to the multiplexer, where it compares both the signals like output of the system and the step input signal and gives us the results on the waveform. So without wasting time, let's run the simulation and observe the waveform. So here we can see that the output waveform of the system which we are observing on the scope. The yellow line represents the reference input signal which is given by the step input. The blue line represents the system output which is the output of the transfer function. Initially the output rises quickly due to the proportional action. We can observe a small overshoot above the reference value. Like at the starting the small peak overshoot is there, but there are some oscillations caused by the system dynamics. Gradually the oscillations reduces due to the derivative action. Finally the system settles at the desired value, showing zero steady state error due to the integral actions. So this shows the PID controller improves like stability, accuracy, response of the speed. Hence the system achieves a smooth and control output. As we have seen the open loop system as well as the closed loop system. In open loop system there is no feedback path, hence the peak overshoot is very high than the reference value. In closed loop system the oscillations are along with the steps reference but not as per the proper output. But here in the PID controller system, the firstly the output shows some oscillation in the starting, but after the period of time the oscillation settles down, and here we can observe the constant and smooth waveform as similar to the reference value. This is the benefit of the PID controller. PID controller is the most widely used controller which are using in the control system to get the error free and the smooth functioning of the system. Now in conclusion we can say that block diagram modeling provides a simple and effective way to represent and analyze the control system. By understanding the open loop system, closed loop systems along with the feedback mechanisms, system performance can be improved significantly, as we have discussed in all the three models recently. Block diagram reduction techniques help simplify complex systems, making analysis easier, as block diagram reduces the system in a simpler blocks. Then the use of the PID controllers further enhances accuracy, stability and response of the system. Overall, this study helps in designing efficient and reliable control system for a real world application. Thank you.